All right, welcome everyone. Thanks for making it for our webinar on autoimmune disease. If you guys can hear us and see us, let us know. Got some people saying, is there supposed to be sound? Make sure your sound is turned on. That was my problem earlier. Let us know where you are. Hello from Illinois, from Cape Cod. Awesome. Okay, and those of you who are here, can you hear us? You can see us. We're lively, can hear and see you. Awesome. Okay, great. Awesome. All right, so there's about 150 of you so far. Cool. So we'll go ahead and get started. As you know, this is Karan Krishnan. He is our microbiologist and the chief scientific officer for us at Microbiome Labs. My name is Acacia. I'm a registered dietitian here at Microbiome Labs, and I'll be facilitating the webinar. So the way this will work, if this is your first webinar, is that Karan will go ahead and give us a PowerPoint presentation for about 30-ish minutes. Sometimes he runs a little longer. And then you guys can ask us your questions in this little chat box. Anytime you have a question, I'll mark it as a question. As soon as he finishes, we'll take about 20 minutes to go through a Q&A. Any question that we don't get to, we will save, we'll compile, and we'll send those out to you guys via email afterwards. So we do always get this question over and over again, but you will be able to get these slides and you will have access to this replay if you came in late or if you have to leave early for whatever reason. So you guys will totally get to replay this if you miss it, and let's go ahead and get started.
Yeah. You want me to jump in?
Sure, if you're ready, unless you want to prep it.
I'm ready.
Okay.
So thank you guys, first of all, for joining us. That's it's so awesome to see so many people on here, and it makes all of the reading and all of this studying of papers and all that stuff worth it if I can share this information with you. I've previously done autoimmune webinars before, and a lot of times I focused on kind of the nitty-gritty of what's going on in the immune system itself. This one, I wanted to really focus on the triggers, what we call environmental triggers for autoimmune disease. And that, to me, is really, really important because it's the most practical aspect of the disease in terms of what's really driving the disease, what typically creates the onset of the disease, and then also the thing that tends to prevent the disease from being able to be cured. So that's a very important aspect of it. So this one, the PowerPoint itself is fairly short, I think only 16 or 17 slides, but I really want to kind of hit home on the really important aspects, which are the environmental triggers, how that plays into the entire auto that are required in order to cause the disease itself. And there's a milieu of things that have to happen in order for autoimmune disease to actually occur. So we'll focus on that, and afterwards, of course, we'll have Q&A, and hopefully be able to answer questions that you might have. So I'm going to jump into the screen sharing here, and then once I share the screen, Acacia will verify that that's being shared properly. Okay, does it look right, Acacia?
Yep, that looks good.
Okay, awesome. So in general, autoimmune disease, there are over 100 different types of autoimmune diseases now. Interestingly, just a couple decades ago, there were maybe half of those numbers. And it's not that these diseases are just popping up out of nowhere. And that's what's really indicative of what is really driving the condition. If genetics played a significant role in autoimmune disease, meaning people who have autoimmune disorders have some sort of genetic defect in general, then the diseases would have increased in prevalence over a longer period of time, because the prevalence rate for autoimmune disease today compared to the prevalence rate of autoimmune disease even 50 years ago cannot be explained by genetic changes. So it has to be something outside of genetics, and that's the environment. And the environment that we live in. Now, the fact that there are so many different autoimmune diseases nowadays means that the resulting autoimmunity is ending up by attacking many different types of tissues within the body, and the different types of tissues are increasing in prevalence as well. That, to me, and there are papers that would agree with this hypothesis, shows that there is additional compounding conditions that are increasing the types of tissues that autoimmunity can attack. And I'll go into that a little bit more when I show you some of the triggers for autoimmune disease, so that you can understand why, now we have autoimmune diseases of the skin and a variety of autoimmune diseases of the skin. Those are the brain, those of the of multiple components of our endocrine system. We have autoimmune diseases of our joints and our eyes and our tongues. It's a really, really pervasive condition. But the fact that it can affect so many different types of tissues in the body means that there are several compounding factors that work together in order to make that possible. So a couple other facts about it. The NIH estimates about 23.5 million Americans suffer from autoimmune disease. The number is rising. I think it's going to be 50 million here pretty soon. That's a lot. That's a significant amount of people suffering from this type of condition. Also, the recent review concluded that the worldwide rates of things like rheumatic, endocrinological, gastrointestinal, and neurological autoimmune diseases are increasing by 4 to 7% per year, which is really, really significant. If you take 4 to 7% in view of the entire global population, that's a huge number of people. And the greatest increases are happening in celiac disease. I'll show you why that is. Type 1 diabetes, another reason I'll show you why that is as well. And then myasthenia gravis, which is a fatigue of the muscles. I can show you why that is as well. And the greatest increases are occurring in countries in the northern and western hemisphere. So again, there's more evidence for why that would be as well. And that'll be part of the trigger component of the PowerPoint. So you'll start to see. Now, in general, one of the things that we know for certain is that inflammation is really the biggest driver of autoimmune disease. But it's a specific type of inflammation, and the inflammation is the milieu under which autoimmune disease can brew. So we'll cover that as well. We'll talk about all of the compounding factors, and then how inflammation allows the autoimmune condition and the autoimmune response to actually show up. Now, here's a couple important things. I mentioned this before, but the best estimates are that 30% of autoimmune risk is genetic, but 70%, and some estimates are a little bit higher, of autoimmune risk is environmental. The biggest components of that are diet, toxic chemicals, and infections. So that's what we'll be focusing on today. Now, those triggers, basically that's diet, chemical toxins, and infections, they disrupt immune homeostasis. So what happens is that you get these environmental triggers, they enter the body, right? So whether it is a toxin that comes in through your food, through your skin, something that you breathe in, whether it's a pathogen that enters or a pathogen that exists within that has a chance to proliferate, whatever it may be, the environmental trigger, the first thing it does is it causes a breakdown in oral tolerance. I'll explain what that is in a schematic coming up, but basically it breaks down the ability of the immune system to recognize self from non-self proteins. And that is driven in the perspective of inflammation. Once you have a breakdown in oral tolerance, you end up getting changes in the gut microbiota, and you get enhanced permeability. In part of that is because the breakdown of oral tolerance increases inflammation even more. So it's a kind of a feedback loop when you have inflammation that causes enhanced oral reduction in oral tolerance, and then the reduction in oral tolerance also further increases inflammation. All of that, of course, increases gut permeability and significant changes in the microbiota. When that happens, then you get even more inflammation. So the system kind of feeds itself. So it has to be stopped at some point, and we'll talk about where are the areas that you can focus on stopping it. Once you have that kind of inflammation and it's chronic, then you end up with immune reactivity. Because you have no tolerance, so your body can't recognize self from non-self proteins, it becomes extremely reactive, and it focuses primarily on certain types of reaction that drive even more autoimmune conditions. We'll also mention what those kind of reactions are as well in upcoming slides. And then finally, you end up with autoimmunity. And again, the autoimmunity can be varied. Somebody who starts off with lupus can very easily end up with Hashimoto's, and then very easily end up with skin disorders like eczema and psoriasis. And then further, it can end up with other metabolic autoimmune diseases as well. Can end up with celiac and other things that happen within the gut. So this is kind of the general cascade. It starts with environmental triggers. There are a couple of predispositions. I'll mention that in the next slides coming up. But once you have a significant amount of exposure to certain environmental triggers, you end up breaking down oral tolerance. That increases inflammation. The inflammation increases dysbiosis in the microbiota and enhanced permeability, which further increases inflammation. That combination increases immune reactivity. So now your immune system is basically reacting to a whole bunch of things that it wasn't reacting to before. And it's doing it in a particular way with a particular type of inflammatory response. And then that will lead to many different ways of inducing autoimmunity in general. So let's talk about the induction of autoimmunity. It requires three components. The first part is some genetic predisposition. Now, it is possible to induce autoimmunity without a genetic predisposition. So that is an important point to make, because even if you don't have a genetic predisposition, you can end up with an autoimmune disease if you have the other two parts of this pillar. That's environmental triggers, and a significant amount of them. When you see the examples of environmental triggers I present, it'll give you an idea of how saturated our exposure levels are to these particular environmental triggers. And then the third part is dysbiosis and inflammation, which a lot of people already have. And a lot of it is even driven by environmental triggers. So the environmental triggers actually set you up for the third leg of this triad of disease, and can be the biggest driver of all of it. So if you have 2 out of the 3 of these, you can induce autoimmune disease. You do not have to have genetic predisposition, but you can have genetic predisposition, and you can be controlling your dysbiosis and inflammation, and you can be reducing your exposure to environmental triggers and never develop the disease. Or even if you do have exposure to certain environmental triggers, and yet you are controlling your dysbiosis and inflammation, you can dramatically reduce your risk for ever developing the disease. So some of the genetic predispositions are SNPs in your NOD2 receptor, which is a pattern recognition receptor. What that is not that important, but basically these things, SNPs in your toll-like receptor 9 or interleukin 10 expression of vitamin D receptors, these things basically perturb immune response. And when you have a perturbed immune response, even if you have things being set up the right way within your system, you could end up with a tangent in your immune response that creates the types of inflammation that can lead to autoimmunity. Interleukin 10, for example, is a type of interleukin that prevents or protects against inflammatory response. So if you have a defective system of triggering interleukin 10, then it's harder for your body to shut down inflammation. So those are some of the SNPs, but again, you don't have to have the SNPs to get autoimmunity. It does increase your risk, but about 30% of the risk of autoimmunity is by genetic predisposition. Some of the environmental triggers, and we'll go into this a lot more, but chronic viral infections and bacterial infections, I'll show you many more of these. 50% of IBD patients have Epstein-Barr virus in the mucosa. 100% of refractory IBD have Epstein-Barr and cytomegalovirus. Coxsackie virus has a huge implication with type 1 diabetes. Antibiotic use, diet, toxin exposure. Again, I'll talk more about these in the upcoming slides. And then within the dysbiosis inflammation side is disruption in the microbiota. When you have a disruption in the microbiota, you end up getting a disruption in the crosstalk between the immune system and the microbiota. So the microbiota communicates with the immune system through things like toll-like receptors, antimicrobial compounds, indole, taurine, histamine, all of these things that are important communication devices between the microbiota and the immune system, and also through pattern recognition receptors. Those are all really, really important components that are part of a good, diverse, healthy microbiome. When you lose the microbiota diversity and you have a disruption in the population, you end up losing that crosstalk and that very important communication between what the body's exposed to and how the immune system should react. Right, so that's a general overview of that part. Inflammation in intestines, and of course, systemic inflammation. As I mentioned, inflammation is a swimming pool that autoimmunity swims in. Right, without inflammation, it's very hard to induce autoimmunity. With inflammation, autoimmunity risk is dramatically higher, and nothing can trigger inflammation more than a dysbiotic, inflamed intestinal section of your body. So you've got a microbiota that's dysbiotic that leads to significant inflammation in the mucosa, significant inflammation in the intestinal epithelium, and that leads to hyperpermeability and of course disruption in crosstalk. So you end up getting significant inflammation in your systemic immune response, and then of course a whole bunch of things leaking through, causing further inflammation inside the body as well. So the biggest surface area in your body is in your digestive tract. And so if the digestive tract is inflamed, it's going to stimulate inflammation all throughout the body. One of the biggest things that does that on a regular basis is LPS, which we've talked about a lot. So LPS triggers the kind of inflammation that sets up autoimmune disease. I'll show you what that is as well. Now, one of the things I want to bring up is something called autoimmune syndrome. Most people may not have heard of this, but it's something that we're focusing on because the thing is, autoimmune disease takes decades to unfold, right? It could have started with a course of antibiotics that you took as a child for, say, strep throat. And that would have set your body in motion to potentially develop autoimmune disease 10 years, 15, 20 years later. Now, if that course has not been corrected, then your body will continue to move towards the predisposition of having autoimmune disease. And then in that case, it takes a single environmental trigger to kick off the disease. So autoimmune syndrome is a condition where the pathology has not become severe enough to be able to label it as any particular autoimmune disease. Because remember, autoimmune diseases are named based on the organs or tissues that it impacts. So even though you have an autoimmune-like immune response to the environment around you, it hasn't gotten so far that it's attacking a specific type of tissue to a point where you have significant degeneration of that tissue. Once you have detectable significant degeneration of that tissue, then doctors are able to put a label on your condition. But that condition existed even the day before you were diagnosed, and likely the decade before you were diagnosed with it. So this is really important. We're actually doing a study on autoimmune syndrome where we're looking at subjects that present with a pro-autoimmune type of response and symptomology, and then we're trying to see if we can rescue their body from going down that path. Now, many of you can actually relate to some of these symptomologies because subjects typically present with things like fatigue and kind of fatigue of unknown cause, right? It's not like they've been going really hard at work or just ran a marathon kind of fatigue. It's of unknown cause, and they seem to be getting plenty of rest. Of course, malaise comes along with that. Low-grade fever from time to time, where you just kind of feel feverish. You get chills all of a sudden. You check your temperature, you might have a temperature of 99.8, maybe 100. So you don't have a full-blown infection, but just kind of a low-grade fever. Aches and pains, so the body just doesn't feel good. You wake up in the morning not feeling rested, pains, as I mentioned. And then, of course, digestive issues. So then, we talk to so many people on a regular basis that have some form of digestive issues, whether it's just bloating and cramping and just really uncomfortable bowels or intolerance to certain types of foods. And at the same time, they may have a couple of these other symptoms at the same time. They might have fatigue, they might have malaise, they may have some aches and pains, and then also the digestive symptoms. But all of that is kind of unexplained. The origin of it is unexplained. They don't really know what is causing it. And they're trying a whole bunch of different things. They're switching their diet around all the time. They're going from paleo to SCD to vegan diet to vegetarian diet, and then they're doing detoxes They're doing all of these different things to try to figure out, well, why is it that I just feel like crap? But in many cases, it's likely they are on the path of autoimmune disease. They are suffering from what we call autoimmune syndrome. So then it becomes important to at some of their immunological parameters for autoimmune syndrome. We can share that with you guys after the talk because we're using those parameters right now in the study. So what I can do is I can pull from our study protocol exactly how we are trying to diagnose people with autoimmune syndrome and then share that with the group afterwards. So here are some of the environmental triggers of autoimmune disease. There are three major categories, like I mentioned. There are foods, toxins, and pathogens. And basically, these environmental triggers, they activate the immune process that ends up leading to the activation of immune cells that can become autoimmune. And these triggers can cause both immunological and chemical changes to antigens that your immune system are seeing. And these antigens will end up being the things that trigger your immune system to actually start attacking various parts of your body. So that's the general overview of this. Basically, what happens first, and this kind of gives you a schematic of what are the steps that are involved once you start getting the significant chemical exposure. So let's say we start with a chemical exposure right there in the bottom, and that can be, again, a food, or it can be a toxin, it can be a chemical compound, it can be a pathogen, but it starts with exposure and long-term prolonged exposure. Then the next thing that can happen is you end up getting genetic factors that change and barrier breakdown. So chemical exposure, especially things like cigarette smoke, can actually cause epigenetic changes within the microbiome and also within our own DNA. And those epigenetic changes cause dysbiosis or cause a breakdown in the homeostasis of the immune response. And then that can, of course, then cause barrier breakdown, and you can end up with more permeability. You can end up with significant inflammation that starts driving the entire condition. Then you end up with parent compounds or metabolites formation. So what that means is the chemical exposure themselves, and I'll show you in another schematic coming up, the chemical exposure themselves can actually be a trigger to the immune system, or they can trigger your cells or your microbiota to produce new metabolites based on the stimulation from the chemical exposure itself. And then those metabolites will go out into the body and start causing oxidative stress, and then cause the formation of something called neoantigens. Neoantigens are new antigens that your immune system has never seen before. And that can be created. I'll show you in a couple of slides how that's created. But basically, exposure to certain chemicals can cause the release of antigens in the body that your immune system's never seen. Now, when your immune system has never seen an antigen, the first thing it does is it activates T cells and macrophages that are very pro-inflammatory. And those pro-inflammatory T cells will kinds that actually create antibody production against that neoantigen. A lot of times that neoantigen then will look similar to an antigen from some other part of your body, and that's what will cause the cross-reactivity. Or it might cause something called the bystander effect, which I'll explain towards the end of the PowerPoint as well. But this is just the flow of information that to give you an idea of what's happening so that you can kind of wrap your head around, what is the sequence of events that occurs that leads to the inflammation and autoimmune reaction. Of course, it starts with the chemical exposure, and as you see in the next 3 or 4 steps, inflammation is driving all of that. And the breakdown of oral tolerance. Oral tolerance is actually modulated and controlled by T regulatory cells. I'll talk about what that does and how we can induce that as well. So it's a breakdown of immune homeostasis in the next 4 or 5 steps that ends up leading to inflammation and autoimmune reaction. So again, this is just to give you an overall schematic. Now, if we can intervene at any one of these stages, we can actually stop the process and the progression of autoimmunity. So here's some food and toxins that trigger autoimmunity. These are important to remember. And when you see the variety of things, it makes you realize how frequently we are exposed to things at fairly significant levels that can actually trigger the onset of autoimmune disease. So first of all, BPA, I think most of us know that we want to have BPA-free plastics and materials, but BPA is still used in 80-90% of plastic compounds or plastic consumer-based products out there. And you just find it in everything. It's an endocrine disruptor, which means that trying to keep a clean environment will become paramount because exposure to something like BPA acts as a significant trigger for autoimmunity. Mercury, of course, from fish and other food contaminants. Mercury has been studied quite a bit as being something that can directly disrupt immune cells and how they function, and can actually change the epigenetics of our immune system and cause it to create an autoimmune response. Asbestos, I think that's a no-brainer. Mycotoxins are a significant risk that is barely discussed. So mycotoxins are incredibly pervasive. They can enter through the skin. They can enter through the respiratory system. They're small enough in terms of their size where they can, actually enter into the mucosal system, through the mucosal system into the circulatory system much easier than almost any other toxin. They are extremely antigenic. They stimulate the inflammatory response in a very potent way. And then they're also very, very prevalent. Most of the foods that we get from agricultural products contain high levels of mycotoxins on them. Things like peanuts. So if you get natural peanut butter, you could have a significant amount of mycotoxin exposure because foods are not tested for the vast majority of mycotoxins. And so our exposure level to mycotoxins are quite significant. And they play a significant role in triggering an inflammatory, unfavorable immune response in the body. Now, what's exciting is, there is a test coming up that we're going to be promoting to our practitioners, which will be the first serum test for mycotoxin exposure. So currently, the only test for mycotoxin exposure is a urine test. Now, the problem with the urine test is it's looking at excreted mycotoxins. And excreted mycotoxins are not necessarily correlated with ones within the body that are causing immunological reactions and triggering disease. One of the reasons for that is because even healthy individuals without any conditions will excrete mycotoxins on a somewhat regular basis because they're consuming it through food. Their system breaks it down, filters that out, and sends them out through urine. So it doesn't necessarily mean what you're seeing in the urine is immunologically active. And it's not necessarily causing any sort of illness. Now, also, the mycotoxins in the urine test are looking at, I think, 5 or 6 mycotoxins. The new serum test that's coming out is going to be looking at mycotoxins that are specifically immunological, meaning they're in the body, they're causing an immune response. And then also, it'll be looking at about 10 different types of mycotoxins rather than 5 or 6. So that's an interesting development that can really help figure out what is going on with the patient when they've cleaned up their diet, they've cleaned up their environment, and yet it seems like we can't do any better with their autoimmune condition. It's more than likely that they have a significant amount of mycotoxin exposure somewhere, or they had it for a while back, and it's still within their system, and we need to end up getting rid of that mycotoxin from their system. TCE, which is an industrial solvent, it's used in things like dry cleaning and numerous consumer products. So again, it's fairly ubiquitous in the modern society. Benzoquinones, which are the base ingredient for the certain class of antibiotics right now. So people use those all the time for upper respiratory infections or strep throat or even sinus infections. Those tend to be a major problem. Formaldehyde, which you find in glues, and in fact, even synthetic vitamins are made or resolved using formaldehyde in some cases. So, if you're taking a multivitamin and the multivitamin contains synthetic vitamin, there's a potential risk of exposure to some small level of formaldehyde on a regular basis. So it's again very prevalent within our environment. Ethylene oxide, which is used in the production of antifreeze, textiles that you have in your house, like your sheets and your curtains and things like that. Of course, it's used to make detergents, which you wash all these things in. So again, significant amount of exposure to these types of common chemicals. Penicillins, of course, as you know, from the antibiotic. Cigarette smoke is a major inducer of autoimmunity. So imagine, someone is working in a like in a bar or something like that, and they're exposed to secondary smoke, which fortunately now in most of the country, there is no indoor smoking. So, but it wasn't that far back, maybe 10, 15 years, where people would work regularly during the day and evening in establishments where they're getting exposure to secondary smoke. They're wearing a uniform or clothes that have been treated by TCE that contain ethylene oxide. And so a combination of these things together can be enough to end up triggering autoimmune disease down the road. Even things like nail polish. Nail polish has been associated with at least one autoimmune disease of the skin, and it can be a significant issue. You would think that's fairly benign, but it is a xenobiotic. It's a chemical that your body has not seen, and our bodies in general as humans have not seen over the course of human evolution. So to the body, it's a very different, unique chemical that can cause significant immune activation. Salt, as far as food triggers, sodium chloride is the biggest food trigger. It directly induces Th17, which is the pro-autoimmune component of the immune system. So salt is a significant thing to keep your eye on. That's a major trigger in food sources. Gluten, of course, is a major trigger as well. Not only is it immunologically active as a protein, which can cause and trigger inflammation in the gut, which of course can then set up the condition for autoimmunity, but also because gluten is often covered with glyphosate, and glyphosate acts as the worst kind of antimicrobial you can be exposed to because it specifically increases the growth of bad bacteria and directly inhibits the growth of good bacteria. It specifically increases the growth of things like Klebsiella, Salmonella. Keep those in mind. You'll see in a couple slides coming up. Even C. diff, of course, and then suppresses a lot of the good bacteria. Just to show you the impact of glyphosate on autoimmunity, this piece of data is actually quite telling. This comes from the USDA themselves and CDC. Basically, it shows the increase in use of glyphosate on wheat and then the subsequent increase of celiac disease. Excuse me, I had to sneeze. Just thinking of glyphosate makes me sneeze. But it's very telling. The incidence rate and the increased pattern over a course of over 20 years is really, really directly correlative between glyphosate use and celiac disease. So again, that glyphosate use is a great example of the compounding factors that I talked about that occurs more and more in modern society, because gluten by itself could possibly create a stimulus for the onset of autoimmune disease, because it is an antigenic peptide. So if your immune system is not really in tip-top condition, your microbiota is not really diverse and strong, you could get this peptide that's coming in that'll then trigger an inflammatory immune response, which can then set up the body for developing autoimmunity. But then when you throw in glyphosate on top of it, glyphosate further exacerbates the condition, because glyphosate gives you this setup where it causes a significant amount of dysbiosis, and then that dysbiosis that's caused by glyphosate directly causes leaky gut as well. So it compounds the whole factor. So remember in the beginning when I was talking about why in modern society, why we're seeing more and more tissues that can end up becoming a victim to autoimmunity, it's because of these types of compounding factors. So not only will the gluten end up causing a celiac disease because of inflammation in the intestines, it will also end up leading to rheumatoid arthritis. It can end up leading to lupus because of the inflammation that the combination of gluten and glyphosate cause, not only locally in the gut, but of course systemically in the rest of the body as well. So this is just one example. I'll talk about a couple more. So how do these compounds actually trigger autoimmunity? So this is the mechanism side of things. If you look here at the very first part, basically the environmental triggers enter the body, and then they trigger APCs. APCs are called antigen-presenting cells. These are typically dendritic cells or macrophages. So the APCs see the environmental trigger, whether it's a toxin, it's a food particle, it's a bacteria or virus, and then in response to that, they release a whole bunch of inflammatory and anti-inflammatory cytokines. So their job as part of the immune system is to go, hey guys, I'm seeing something that looks suspicious and unfamiliar here. I want everybody to wake up in the immune system. And that is the inflammatory side. And then it also stimulates anti-inflammatory cytokines so that the regulatory part of the immune system can wake up as well to pay attention to that reaction to see whether or not it's a reaction that the immune system should go ahead and carry forward. So it releases things like interleukin-1 beta, TGF beta, interleukin 12, interleukin 23, TNF alpha, interleukin 6, and so on. These are all the very, very potent pro-inflammatory cytokines. Now, at the same time, it might also release interleukin 10, which will wake up the Treg cells. So these things are the key drivers of inflammation that can lead to autoimmunity. But then we do have the Treg cells that are a really important component that are supposed to step in and tell the naive T cell, you know what, this is not a reaction that we need to be facilitating, so let's stop reacting to it. And it won't allow the naive T cell to develop into a Th1 cell or Th17 or TFH cell. These are the three types of T cells that will end up stimulating an autoimmune response: Th1, Th17, or TFH cell. And that's a follicular helper cell. So these are all effector cells that end up triggering the production of autoantibodies. And they start from a naive T cell that has been stimulated by interleukin-1 beta, TGF beta, and so on, which are all the pro-inflammatory cytokines. Now, the APC is also supposed to release some anti-inflammatory cytokines, which are supposed to upregulate Treg, so that Treg can oversee this entire process and figure out whether or not it's an important immune reaction to conduct, or it's one that it should stop. The problem is, if you have excessive amounts of inflammation in that environment to begin with, right? Because you have leaky gut, for example. Leaky gut induces interleukin 6 and TNF alpha all the time, constantly in your body. When we did our leaky gut study, if you guys remember those webinars, two of the key cytokines that we're measuring when people had the leaky gut response to the meal was interleukin 6 and TNF alpha, and of course interleukin 1 beta as well. So imagine that the APC, the antigen presenting cell, is seeing some sort of trigger, but it's doing it in an environment that is not already inflamed, right? So then it sees the trigger, it releases the important cytokines, both the inflammatory and the non-inflammatory cytokines, and then that gives the immune system a chance to evaluate, do we need to move forward with this reaction, or should we stop the reaction and develop oral tolerance? So remember, breakdown of oral tolerance leads to the autoimmune response. So this checkpoint is where we have a chance of stopping the autoimmune response, because if we have enough adequate T cell expression or Treg cell expression, it can monitor this whole reaction to see whether or not it should move forward. Now, if it's doing this in a non-inflammatory environment, then there's enough checks and balances between inflammatory and anti-inflammatory cytokines for the Treg cells to do its job and figure out that, you know what, we don't need to respond to this particular antigen, so let's stop the immune reaction here and let's develop oral tolerance. However, if this same schematic is happening in a milieu that is completely inflammatory, meaning chronic inflammation from leaky gut and other things are creating more inflammatory cytokines than anti-inflammatory cytokines, then the Treg system cannot work. And this reaction, this meeting of the antigen-presenting cells with the environmental triggers will almost always lead to a amplified inflammatory response. And that amplified inflammatory response can end up producing Th1 cells, which can then cause tissue inflammation and tissue damage, or Th17 cells, which can do the same. And if either of those does that tissue inflammation, tissue damage, you could end up having an autoimmune response to that tissue. Or TFH cells, which can start producing antibodies to the injured tissue that is getting injured in the immune response. So I hope that makes sense, that why an inflammatory medium can screw up this regulatory part of the immune system. It messes up the checkpoint of where the naive cell, before it matures into a pro-inflammatory and an autoimmune inducing Th1, Th17, TF8 cell, it has the capability to be stopped by the FOXP3 positive Treg cell. But if the environment is pro-inflammatory, it cannot be stopped. So that's why inflammation induces autoimmunity. Now, toxic chemicals themselves can induce autoimmunity in another way as well. So the toxic chemicals can actually directly enter the tissue. Once it's in the tissue, it can damage the tissue to a point where it can covalently bond to certain parts of your own tissue. Now, when this toxic chemical covalently bonds to a certain part of your tissue, to the immune system, that no longer looks like the antigen that it knew before, which is your own tissue. Now it looks like a totally foreign molecule because it has a component of it that it does not recognize, but it still has a component that looks like your tissue. However, the immune system is going to treat it like something new. T cells are going to come across it because of antigen presenting cells, and then T cells are going to stimulate B cells to make antibodies against that entire compound. But because it's making antibodies against that entire compound, it also includes the component that is your own tissue. So that's the top part of this reaction. The bottom part is the induction of completely new antigens, and that's the formation of what we call neoantigens. So the chemicals can actually get into your system. It can end up binding covalently in 2 or 3 places with your own tissue components or components within the cell itself, and then it can leave the cell, and it looks like a completely new antigen to your immune system. Your immune system develops a bunch of antibodies to protect your body against this new antigen, but then this new antigen has enough similarity to some part of your body that it'll start causing an autoimmune response within the body. So this is how a toxic chemical can directly impact an autoimmune response, even outside of the previous mechanism that I showed you. Now, pathogens and infections can also stimulate autoimmune response, and they do it in 4 distinct ways. The first one is through something called molecular mimicry, right? So certain pathogens have been able to develop aspects of themselves. So aspects meaning epitopes of themselves that look exactly like certain epitopes within our own tissue. Now, the reason it does this is because if it looks like our own tissue, it can avoid immune detection. So that's what's called molecular mimicry. So it comes into the body, or within the body itself, it is given a chance to proliferate. And then once it's proliferating and it's causing immune tissue damage or it's causing cell damage, then your immune system comes in and tries to attack it. Now, when the immune system comes in, it sees this thing that's causing tissue damage, and it develops antibodies against that thing. It just so happens that that thing also looks like your myocardium, or it also looks like your joint, and it looks like some other part of your body. And so then those antibodies, as they're circulating around, will start attacking your own joints as well. So that's called molecular mimicry. It can also do something called epitope spreading, which is actually really interesting. So these pathogens, especially like a virus, can get into your cell, and it takes over the cellular machinery. When it takes over the cellular machinery, it makes your cells produce all kinds of proteins and things like that that favor its own survival. Then eventually your cell bursts, and then all of those things are released into your circulatory system. So the types of epitopes that these viruses and bacteria stimulate can then be spread through the rest of the body, and then those epitopes have a similarity to certain parts of your own tissue, and again can induce an autoimmune response because of those similarities. But it's spreading those epitopes from a single point of infection. It can spread it through the rest of the body. Dysregulation of the immune homeostasis, again, this is when you have chronic infections like cytomegalovirus and EBV, it can keep your body in that pro-inflammatory innate response area where autoimmunity starts to breed. So the way your immune system is supposed to work is the innate immune response, which is the inflammatory immune response, starts the process of the immune response against whatever is potentially targeting the body. But then it's supposed to transition into the adaptive immune response, where the body either adapts and develops oral tolerance to that antigen, or it goes ahead and produces antibodies to that antigen to sequester it and neutralize it this time, and then the next time it seizes it as well. But then when you have a significant amount of chronic infection, it can create a dysregulation where your immune system is more pro-inflammatory than anything else, and it's not really evolving to that adaptive side of the immune response. The last thing is something called the bystander effect. So imagine a virus comes in and starts, infecting a certain part of your body. Let's say it's affecting your neurons, so a certain type of your neurons, part of your central nervous system. It's causing an infection and inflammation in that part of your body. Now, when the virus is there and it's causing the infection, the inflammation drives a bunch of immune cells like natural killer cells and other types of T cells to the location. Once those get there, they start attacking everything in that region because they're not so specific. They're not part of the adaptive immune response. They just kind of attack the entire area. Now, when they're attacking the entire area, you can get tissue damage of your own tissue. When your own tissue gets damaged, it can release little compounds from your own tissue that end up becoming antigenic. So your own tissue ends up being a bystander in the immune battle against a virus or bacteria in that local space. Because your own tissue ends up getting damaged and releasing components of itself, the immune system sees it and goes, hey, I don't know if that's a component of the bacteria or a component of my own cell, so I'm going to develop an antibody against it anyway, just to be safe. And then now you have antibodies that are attacking your own tissue. So that's called the bystander effect. Now, the amount of work that has been done to identify the microbial or viral or infectious pathology correlation to autoimmune disease is quite significant. And they've identified many viruses and bacteria that have very specific impact on certain types of autoimmune disease, or in fact, are the major trigger of certain types of autoimmune disease. That's what you'll see in this next slide. So here's some examples. Things like Yersinia can induce rheumatoid arthritis. So these are all of the viruses, fungi, bacteria that have been shown to be associated with just RA. So look at all the different types of infections that can cause RA. Things like C. diff, Klebsiella pneumoniae, Campylobacter jejuni, Candida albicans, chlamydia, parvovirus, Epstein-Barr virus. All of these things are very different types of microorganisms that cause a different type of disease, but they can all create rheumatoid arthritis as well. Now, they do it by one of those four mechanisms I just explained. So, some of these might do it by bystander effects, some by molecular mimicry, some by spreading their epitopes. But it's really staggering when you look at how well documented the various infections are to the cause of even something as singularly as rheumatoid arthritis. Now, of course, with Hashimoto's thyroiditis, there's a whole bunch of other ones. So Coxsackie virus, rubella, mumps, hepatitis C, parvovirus, Epstein-Barr, all of these things have been shown to cause autoimmune response against your own thyroid through one of those four mechanisms. So infections and pathogens are a major driver of tissue-specific autoimmunity. And this is just a small example of it. This is just RA and just thyroid. When you start looking at all of the other autoimmune conditions, if you look at lupus, if you look at eczema and psoriasis, you see a whole bunch of these examples as well. So again, these are a huge driver of autoimmunity. So between the chemical toxins that we talked about and the pathogens, they are really the major drivers of autoimmunity. And imagine you already have an autoimmune condition. These microbes, these viruses, can actually exacerbate the condition and then create new conditions. So this is one of the ways in which somebody goes from having lupus to Hashimoto's thyroiditis, because lupus can be stimulated by, let's say Klebsiella, or it can be stimulated by a viral infection, and then because the virus is still there or the bacteria is still there, it can further down the road induce the attack on the thyroid as well. So you can end up with Hashimoto's as well as lupus. So being able to deal with these chronically infective or even acutely infective pathogens becomes extremely important in dealing with autoimmunity. And just to show you, again, because glyphosate is one of the worst things that we've done to our society, which is really sad. Glyphosate. This shows you the incidence rate of deaths due to intestinal infections in compared to increased use of glyphosate on wheat. And again, the correlation couldn't be more clear. Infectious deaths by infections increased dramatically with the use of glyphosate. And as we just talked about in the previous slide, all of these infections lead to autoimmune disease. Glyphosate has been easily shown that it increases the rate of infection. So again, this is one of those compounding triggers that causes the wide variety of autoimmune conditions in modern society. Because as we talked about before, if you're doing wheat and glyphosate, then the wheat itself is antigenic, can start triggering inflammatory responses. Then the glyphosate comes in with the wheat, creating dysbiosis and increasing leaky gut, which then drives the formation of autoimmune disease. And at the same time, glyphosate also increases your risk for developing overgrowth of pathogens. And we've shown in the previous slide that the pathogens can then increase other autoimmune diseases as well. So it's not unusual to go from eating wheat, getting exposure to glyphosate, and developing celiac disease. And then because of the development of celiac disease and the increase in the growth of pathogens in the gut, that you end up with rheumatoid arthritis, or end up with Hashimoto's thyroiditis. So again, all of these things are compounding factors, and that's the main message that I wanted to put across. Now, the microbiome plays a really important role, and of course, we're not going to get away with any talk of mine without mentioning the microbiome at some point. But the microbiome plays a very important role in either the protection against autoimmune disease or maybe even the induction of autoimmune disease. So here are some of the important details there. We know that low diversity in the microbiome is associated with increased risk of autoimmune disease and even poor outcomes of treatments. And a lot of that is because of the increased incidence of infection. So a low diversity microbiota is much more susceptible to infection by things like Campylobacter or C. diff or Klebsiella, and these things that would get in there and trigger autoimmunity from the pathogen side. So the diversity of the microbiome is paramount to maintaining homeostasis. We also know that low diversity in the microbiome stimulates inflammatory responses rather than oral tolerant responses. So that becomes a really important factor as well. Low diversity is also associated, of course, with leaky gut and increased LPS secretion. We know that leaky gut and increased LPS secretion increases the inflammatory response within the body. So now your body is basically sitting in a pro-inflammatory swimming pool. And we know that inflammation is the swimming pool that autoimmune swims in. And so if leaky gut and if increased LPS is creating inflammation in all different parts of the body, then when you do get that other environmental trigger, like you are exposed to BPA and you are exposed to Coxsackie virus, that combination of things within that inflammatory setup will lead to autoimmune disease because your Treg function is not working. Bacteroides fragilis promotes Treg expression. Example is the PSA from this bacteria, so it can prevent RA. So there's been studies that show that you can ferment this bacteria and you can pull out some of the metabolites, which include a metabolite called PSA, that has been shown in mouse models to be really effective in reversing and preventing the development of RA. So we know that Bacteroides fragilis is a normal commensal organism, and it's a major part of the microbiome. And so this is one example of how the microbiota can protect against autoimmune response. Another one of my favorite bacteria Faecalibacteria prausnitzii, which makes up about 5% of the total microbes in a healthy adult's microbiota. In fact, it should be between 5 and 10%. It has a significant capability to protect against inflammation and the induction of autoimmunity by inducing the FOXP3 positive Tregs system. Remember, that's the regulatory part of the immune system that gets minimized in a system that is heavy with inflammation. So it can't do its job as a checkpoint for the maturation of naive T cells into Th17 or Th1 or TF8 cells. So again, bacteria like Faecalibacteria prausnitzii are able to induce the further expression of Treg cells. That's a very important aspect of it. Even other bacteria like Akkermansia muciniphila, which can make up, again, 3 to 5, even 7% of the microbiota, can restore the mucus layer via the release of MUT. And high-fat diets and obesity tends to thin the mucus layer and tends to suppress this particular type of bacteria. It also increases the endocannabinoid content within the gut and also systemically. So one of the things that Akkermansia does to protect against inflammation in the body is increase the expression of the endocannabinoid system. The endocannabinoid system, as you might know from talks on cannabinoids and THCs and of course CBD, is that an increased binding of the cannabinoid receptors reduces inflammation overall. So this is one way that Akkermansia does its job of reducing the risk for autoimmunity by increasing the expression of endocannabinoids receptors, so that when the receptors bind, they can actually reduce inflammation in the body. Of course, it also helps restore the barrier function of the intestinal lining by improving the production of mucus. Non-infectious Clostridia, so infectious Clostridia like C. diff, Clostridium preferenges, and tetani will stimulate autoimmunity, but non-infectious Clostridia can be a very powerful upregulator of the Treg system. They can get a little bit deeper into the mucus layer and stimulate the production of interleukin-10 and TGF-beta to reduce inflammation in the gut lining. Now, what's interesting is the spores in megaspore also increase interleukin-10. That's one of the things we saw in our clinical trial that we published last year. And I just got a report confirming, and we were finishing a clinical trial on the SHIME model system where we were looking at to see evidence whether or not the spores increase the growth of Akkermansia and Faecalibacteria. And as it turns out, the spores do increase the growth of Akkermansia and Faecalibacteria, which of course will then help protect against autoimmunity. So that's one of the ways that the spores really help with autoimmunity, is by increasing interleukin-10, TGF-beta, also increasing the growth of Akkermansia and Faecalibacteria. Bacillus spores themselves can stimulate Treg system and of course produce high levels of short-chain fatty acids, which would support the healing of the gut and actually reduces inflammation in the body. And even things like small filamentous bacteria can upregulate Th17, but without upregulation of interleukin-17. So it offers the inflammatory protection of Th17 against viruses and bacteria without the risk of going towards interleukin-17. So it can help fight things like fungus and other pathogens without actually stimulating autoimmunity. And some studies show that even an overabundance of lactobacillus can lead to stimulation of autoimmunity. So you want to be careful with these kind of kitchen sink probiotic formulas that use generic strains of lacto and bifido, and then they have these unusually high doses. Too much of those antigens from bacteria can stimulate an inflammatory response, which can then perturb the immune system. So in general, these are the things in play that end up causing autoimmune disease. You need to have the dietary components, which are part of the environmental triggers. The same thing with the toxic chemicals. They are part of the environmental triggers as well. Then when you have the genetic components and then you have infection coming in, when you have 3 or 4 of these components together, the overlap regions cause autoimmune disease. You don't have to have all 4 of them, but if you have 3 out of the 4, you certainly be at significant risk for autoimmune disease. Now, the point I want to make, which is something that people forget, is once you do have autoimmune disease and you're trying to recover from it, if you have a patient with autoimmune disease and you're working hard to help the patient recover from it, you still have to pay attention to all of these triggers, because all of these triggers, especially the infection side, will continue to propagate the disease. And not only will it continue to propagate the disease that you're targeting, but it will start to induce other additional autoimmune diseases as well. So it becomes really important to pay attention to this overlapping region. And if you're treating autoimmune disease or you're looking to prevent autoimmune disease, you've got to remove at least 2 out of the 4 of these components. One of them cannot be touched, the genetic component, but the other 3, you've got to start looking at how do we make really significant steps to reduce the negative impact of all of one of those or 2 of those 3 components. Because if you can remove 2 of the 3, then the risk for developing autoimmune disease is very, very low. So in conclusion, the induction of autoimmune disease, of course, will have a genetic component to it. If you have genetic predisposition, of course, you have a much more significant risk of inducing autoimmune disease. But the biggest parts of it are the environmental triggers that we talked about. And then, of course, the environmental triggers with respect to being in a situation of a sort of severe dysbiotic flora, and then inflammation that goes along with it as well. So then, in our view, the most important thing is you can't do anything about the genetic predisposition. We can't change our genes, so we have to focus on the 2 things at the bottom of this triad of disease. The first one being environmental triggers. So we have to dramatically reduce our intake of sodium. Sodium is one food component that has a direct stimulation of interleukin-17, which is a major cytokine that drives autoimmune disease. So sodium intake has to be significantly reduced if someone is either at significant risk for autoimmune disease or is dealing with an autoimmune disease right now. And that's something that people don't look at that often, because I talk to people all the time who are dealing with autoimmune disease and they've gone to like an autoimmune paleo diet or some other diet. And so they're changing the macromolecules that they're consuming, but they're not paying attention to the sodium, right? So if you're doing a paleo a diet, but you're seasoning things very liberally, and you really have a palate for high sodium, you're not watching your sodium intake, and that's continuing to drive the autoimmune disease. Of course, growing your own food is the only way to really minimize glyphosate exposure. A recent study came out that showed that even organic food had almost the same amount of glyphosate as foods that were that glyphosate was actually used on. So the most effective way to avoid glyphosate exposure is to grow your own food in your backyard. And I'm talking about your produce. If you can get away for a period of time from eating processed grains, that's great. So get away from grains and anything that processed grains are made out of. But then for your vegetables and fruits, instead of going to the grocery store and buying it, try to grow some of your own so that you can reduce your exposure to glyphosate. Because again, even organic vegetables and fruits have glyphosate residue on it. In some cases, it was just as high as the non-organic stuff. Go as natural as possible when it comes to your household. Like, for example, I don't use any cleaning solutions in my household. We just wipe it with a cloth with a little bit of essential oils and water, because again, you don't need to sterilize your household. Even your detergents, your personal care products, as clean as possible, makes a significant impact, because all of these chemicals get in and act as chemical and environmental triggers for autoimmunity. I always tell people, don't put anything on your body that you wouldn't eat, right? So if you have shampoos, soaps, moisturizers, and all of these things that you would typically put on your body, if you wouldn't eat them because they have an ingredient list that looks really scary, then I wouldn't put it on the body, because these toxins can be absorbed through the skin and through the respiratory system when you're applying them into the mucosal system and act as a significant environmental trigger. If there's a patient that's dealing with an autoimmune response, but he or she is still using personal care products that have all of these chemicals, some of which I listed in that other slide, then they're going to continuously be inducing the autoimmune response within their system as they're trying to fight it. Of course, avoid gluten and any crops where glyphosate is used as a desiccant, like oats, for example. And this one, most people don't know. You might think that avoiding gluten will help you avoid glyphosate in general, but there are a number of crops that glyphosate is not used as an insecticide or herbicide. It's actually used, or weed killer. It's actually used to desiccate the crops right before harvest. Oats is one of those. So oats, in the U.S., the oat fields are soaked in glyphosate just before harvest in order to dry everything out so that they can make harvest easier. So you might think, you know what, I'm avoiding grains. I'm not eating wheat. I'm not eating corn. I'm not eating soy, but I have my steel cut oatmeal in the morning, and that is healthy for me. But in fact, the oats are more than likely soaked in glyphosate and tend to have a very high level of glyphosate themselves. So you have to be extremely careful, be more investigative, and start looking for things that have a much more cleaner profile. Then on the dysbiosis and inflammation side, of course, one of the first things you can do is diversity. Diversity is so important, which means trying to expand the repertoire of food. Of course, we want to stay away from the foods that are heavily processed, that have glyphosate and so on, like we talked about, but increasing the repertoire of things like nuts and seeds and roots and tubers. And a lot of times, because some of those things aren't grown here in the States, you might actually find cleaner versions of those than anything that's grown here in the States, because in some of these other countries where they come from, like cassava, for example, coming from Latin America or coming from Africa, there's no glyphosate used on those cassava plants. So when you're getting cassava imported from overseas in the form of a flour or whatever, or flakes or whatever it may be, the glyphosate residue on it tends to be much, much lower than even organic food that's found in the U.S. Now, interestingly enough, in that study I was talking about with Megaspore, that I just got the final report today, where it showed that Akkermansia and Fecalum bacteria levels were growing with Megaspore. It also showed a significant increase in diversity of the microbiome when you add Megaspore in. So that's one really interesting effect of Megaspore itself. Must resolve leaky gut, which is the biggest driver of chronic inflammation. It's the biggest thing that causes inflammation in virtually every part of the body where that part of the body might come in contact with an environmental trigger, which might then induce the process of autoimmune development, because again, your Tregs aren't functioning in that heavy inflammatory site. And so that becomes a really important thing, is to resolve leaky gut. Of course, so far the spores are the only thing that have been shown to do that. Avoid prolonged exposure to antimicrobials. Of course, you should never be using antimicrobial soaps on your skin and all that, but even the prolonged use of natural antimicrobials, people have this false conception that because it's natural, it's okay to use it. And I've met people who have used oregano oil for a year every day of their lives. And that can create a significant perturbation in your microbiome. Even though it's natural, it does kill bacteria, and it doesn't necessarily kill bad bacteria only. It kills both bad and good bacteria. So any sort of prolonged antimicrobial use is just not wise. And then you want to upregulate the Treg system, and you can do that by reducing fat intake and increasing plant-based foods, because those plant-based foods increase Fecalum bacteria and increase Akkermansia. And high fat intake will actually reduce the growth of those bacteria and also reduce the growth of bifidobacteria and actually lead to a dysbiotic flora. Now, one of the things that people tend to confuse is, they'll say, well, because I'm autoimmune, I'm doing the autoimmune paleo, and autoimmune paleo, it can be beneficial to them or has been beneficial to them. And they say, well, then, what about the fat component? Well, say that paleo doesn't necessarily mean it has to be high in fat, right? Paleo is really about eating real food and eating foods that our ancestors during the course of evolution had easy access to. And they did not have as easy access to fat as they did complex carbohydrates and plant-based foods. So, even though fat is fine, and if you have a healthy microbiome, you can eat almost any kind of fat and be fine. If you want to increase Akkermansia, if you want to increase Fecalum bacteria, which naturally increases your Treg system, then you want to consume higher amounts of plant-based food than fat in the diet. So that'll increase those key bacteria. It'll also increase the production of short-chain fatty acids, which we know has a significant impact on the health of the lining of the gut, the inflammation that occurs within the gut. And of course, that inflammation then drives virtually all aspects of autoimmune disease. So these are the takeaway messages here. is that these two bottom parts of the triangle, which make up kind of the environmental triggers, are the most important areas to focus on, because these are the things that continue to perpetuate the disease and prevent the recovery from a current autoimmune condition, and also will stimulate the production of new autoimmune responses. So it becomes extremely important to deal with these two aspects of the system. And I think that is the very last slide. So let me come out of this sharing mode.
Phew.
Okay, we said a lot of stuff. I said a lot of
We
stuff.
did.
Um,
You really stirred the nest with the salt thing.
Oh, did I? All right, good.
You're going to have to clarify if you're talking about unprocessed sea salt or processed salt, or both. That's very important.
Okay, so the component of salt that causes the biggest induction of autoimmunity is the sodium part of it. So it's sodium chloride. Now, you can get salt that is higher in potassium chloride, which will have less of an impact. So it's table salt. It's sodium chloride. Now, don't be fooled that sea salt has automatically less sodium. Not all sea salts automatically have less sodium than table salt. Sea salt will tend to have other minerals in it as well, so it'll be positioned as a healthier salt because it has other minerals like magnesium, potassium, and all that in it, but it doesn't necessarily mean it has less sodium. So what you want is salt that has significantly less sodium in it. There are some companies that are coming out with potassium chloride, produced salt, which has very similar salt taste to it, but less sodium in it. But it's the sodium that actually causes the changes in the immune response that directly stimulates interleukin-17, which is the direct trigger for most autoimmune conditions. And that's something people don't look at, right? So they go, I've been on a really clean diet, I've been eating autoimmune paleo, I've been doing this, I've been doing that, but their salt intake is still super high. They're still taking in 1,000 or 1,500 milligrams of sodium every day, and that in itself can maintain a disease.
Good to know. Also, for everyone that's asking, you will still get a video replay. It'll be available later tonight, and we'll send that out via email. You'll get slides, so just stay tuned for all of that. It's coming. Okay, one of the other questions was, how can we increase the diversity of other microbes beyond using the spores? So specifically, the questions were about the mucinophilia and the prosnitzi. So can you speak to like what specific prebiotic fibers those bacteria prefer, or other ways besides spores to increase those?
Yeah, so we have found 2 prebiotics that actually have been clinically shown to increase Faecalum bacteria or increase Akkermansia. And we've put those into a product that we're coming out with called Precision Prebiotics. One of them is a prebiotic from kiwi fruits, and actually 2 of them are prebiotic from kiwi fruit, and one of them is a galacto-oligosaccharide as well, with a high degree of polymerization. So until those products are available, if you just eat kiwi, it can dramatically impact the growth of those bacteria. In particular, you have to eat the core part of the kiwi, and then if you can eat the outside part of the kiwi, that helps as well. Those 2 fibers are contained within the whole kiwi fruit itself. But we've found a source that has purified that, and we'll be putting it in our next product that's coming out called the Precision Prebiotic. And the Precision Prebiotic is designed specifically to increase Akkermansia, increase Faecalum bacteria, and also increase Bifidobacteria. Now, other than that, Akkermansia can also be increased by fasting, because Akkermansia is called Akkermansia mucinophilia. It's a mucin-loving bacteria. So when you're not eating food, there's not a bunch of carbohydrates coming in, Akkermansia can start doing well because it starts eating away some of the old mucin. And as it eats away the old mucin, it increases the production of something called MUT that increases the production of new mucin layer, mucin 2 especially, and that improves the barrier function of the mucosal layer as well. So you get a double whammy there, a good whammy, double good whammy, because you're increasing Akkermansia, and then Akkermansia is increasing the mucin production. So those are the best ways. Now, increasing your diet of a diverse set of carbohydrates will also stimulate these bacteria. I just haven't seen any specific carbohydrates that have been able to increase these bacteria, specifically outside of the kiwi ones that I talked about that we've kind of put into this new prebiotic. But they are carbohydrate-loving bacteria. So the more complex the carbohydrates are, like if you get it from roots and tubers, things that have resistant starches in it, inevitably you will be feeding those bacteria. And those bacteria are extremely important. Fecalum bacteria, for example, is directly correlated with the onset of IBD, Crohn's, IBS. If fecalum bacteria levels are high, it's totally protective against IBD, Crohn's, and so on. But you find in people with very low fecalum bacteria, IBD, Crohn's, colitis, all of those inflammatory bowel conditions and inflammatory autoimmune conditions tend to be really high as well.
Okay, let's see. Can you speak to what you would consider a high-fat diet and if saturated versus unsaturated fats make a difference?
Yeah, so a high-fat diet to me is where you have 40% or more of your daily caloric intake coming in from fats. 20, 25, 30% seems to be okay, especially if you're getting enough of the plant-based foods as well, because the plant-based foods will help increase the types of bacteria that tend to be decimated by continuous high-fat intake. And a lot of that is because most of us evolved from ancestors that did not consume really high amounts of fat. If you are a descendant of an Inuit Indian, then your microbiome is designed to consume very high levels of fat. They take in about 80, 90% of the calories from fat. So the microbiota over time has evolved to deal with that. But most Europeans grew up on a diet of potatoes and carbohydrates and some meat. They did not consume really high levels of fat, like a lot of coconut oil and things like that. So if you're autoimmune, you want to increase the complex carbohydrates because that increases the types of bacteria that protect you against autoimmunity. And high fat increases the types of bacteria that can help trigger autoimmunity, like Prevotella, for example, or Clostridia, E. coli, things like that cause disturbances in the microbiome. So what type of fat? I've talked about before when I do our endotoxemia talks that saturated fat, if you don't have a protective microbiome, can create an LPS that's more toxigenic to the system, so it creates more inflammation. Omega-6 fats can protect against that same type of inflammation. So the type of fat matters as well. Now, I don't want to demonize fat and I don't want to demonize saturated fat. When you have a dysbiotic flora, those things can be bad for you. They can be, or at least not good for you like we think they're good for us. When you have a dysbiotic flora, you're better off eating a lower fat diet and higher plant-based diet. And then, of course, also reducing saturated fat and eating more omega-6 fats. The data shows that those omega-6 fats can be protective against LPS endotoxemia, whereas saturated fats can increase the endotoxemia, which sets up the inflammation swimming pool that autoimmune swims in.
Do you mean omega-3 fatty acids?
Omega-3 and 6, both of them.
Okay.
So omega-6 fatty acids are converted to omega-3 in a healthy microbiome. So if you're taking extra virgin olive oil, for example, extra virgin olive oil tends to have higher omega-6 than 3, but then your microbiome will convert some of that 6 into 3, and then you'll have the protective effect.
Gotcha. Okay, going back a little bit to Epstein-Barr, what are the best ways to test for Epstein-Barr? And if you get a negative result in a blood or stool test, can you really trust that as being truly negative?
Yeah, the best way to test for Epstein-Barr is to look for antibodies against Epstein-Barr, but you want to look for IgM and IgG and IgA. If you see positive in all three, then you know that you probably have some degree of an active infection. So IgM is the long-term immunological memory, right? So if you were ever exposed to Epstein-Barr, you probably have an IgM antibody against Epstein-Barr. But if you have an IgG and IgA response, then it probably means you've had recent exposure to Epstein-Barr, meaning it came back out of its dormant state, which is its latent period. So these viruses can go into latency where they're not immunological, so your immune system doesn't see them, but then they become infective again. Let's say you talk on your phone for 30 minutes. These phones can give you enough radiation to stimulate the pathogenesis of Epstein-Barr. So let's say you talk on your phone, you're stressed, your immune system's down, then Epstein-Barr starts to become infective again, your immune system responds to it, you should see IgG and IgA antibodies as well. So the best way to understand whether or not you have chronic and active infection is to look for an immunological response to the virus, but look for IgA, IgM, and IgG.
Okay. Can you also talk about the best way to test for LPS?
Yeah, so that stuff we've been working on that. We for the study that we use, the lab at the university had their own test, which is not a test that they commercialize or anything, but they got it from another company that supplies research labs with testing for LPS. But if you can't test for LPS, you can test for things that LPS stimulates. One of the things that I always recommend to people is something called soluble CD14. So soluble CD14 is the first part of the immune cascade that LPS stimulates. So if you can test your patients for high levels of soluble CD14, it'll give you an indication that they likely have LPS stimulated inflammatory response in the body. Now, LPS, the reason why leaky gut and LPS are such potent inducers of autoimmunity is because they create that inflammatory pool. Right, and when your body starts seeing antigens in perspective of this inflammatory pool, the Treg system can't work at all, and more than likely you'll develop a pro-inflammatory and then possibly an autoimmune type of response to those antigens. So it becomes really important to deal with the LPS and leaky gut. But we are working on a commercial LPS test, so we might have something for you down the road. But in the meantime, look for soluble CD14. Look for interleukin-6, look for TNF alpha. Those three alone should give you enough indication that your patient or yourself are suffering from LPS endotoxemia. I don't know how to
silence your phone.
No, not my phone, but my iPad. There's no like mute button on it, like my phone has this little thing that I click over and it mutes it. So that's why at one point in the talk, I was getting distracted because my daggone iPad kept beeping at me, and I'm like, how do I silence this stupid thing?
Gonna have to put it on Do Not Disturb next time.
Okay,
exactly. I'll add that to your checklist.
Please.
Okay, the next question was, how do you get rid of mycotoxins in your system?
That's a good question. So that's a more elaborate protocol. So we are working with Dr. Campbell. I don't know if most of you know Dr. Campbell, but he's a immunologist, and he's been specializing in mycotoxins for the better part of the last couple of decades. That's his area of specialty, and he's of course written numerous papers on it, done research work on it. He's acted as expert witnesses in cases of mold and mycotoxin exposure. So we're working with them right now to come up with a really good protocol on mycotoxin exposure and mycotoxin induced immune reaction. Because once we come out with the test, we want to be able to give people a solution as well. Now, a lot of it has to do with improving mucosal immunity, increasing short-chain fatty acid production, because short-chain fatty acids actually increase the efficacy and maturation of peripheral dendritic cells and macrophages. Dendritic cells and macrophages are going to be key components to finding the mycotoxins and neutralizing them. Also, natural killer cells and all of these other peripheral immune cells are going to be a huge part of it. And a lot of that is going to be by improving mucosal immunity and increasing short-chain fatty acid production. So until we come out with the full kind of elaborate plan of how do you deal with mycotoxin exposure, I would say that the best thing to do is try to increase butyrate and other short chain fatty acid production. And the best way to do that, of course, is spores increase that, but also using resistant starches, using complex carbohydrates, and again, going down on the protein intake, because protein will increase proteolytic fermentation. We want more saccharolytic fermentation. So we want to try to get the butyrate going. That'll really help with the systemic exposure to mycotoxins.
Very good, very good. Can you speak to the effectiveness of inulin and other prebiotics that people might try to use to increase diversity?
Yeah, and these prebiotics are really good. I mean, most oligosaccharides are well tolerated and specifically make it to the large intestine and feed certain classes of good bacteria like FOS, fructooligosaccharides. One of my favorite is xylooligosaccharides. XOS, which specifically feeds bifidobacteria. That's one that's going to be in our precision prebiotic. And then there's actazine, which is one of the ones from the kiwi that I talked about. So you can look for that on the market before our product comes out. So I think it's spelled actazin. Galacto-oligosaccharides can be useful as well. Inulin is like an oligosaccharide that gets into the large bowel and specifically feeds good bacteria. So those are all perfectly fine. I totally recommend people using those types of prebiotics in order to stimulate diversity in the large intestine.
Cool. How do you feel about the effectiveness of supplemental butyrate?
So supplemental butyrate is really, it's very unlikely that it does that much. Now, a lot of it is because of its inability to survive through the gastric system and the first part of the small intestine. Supplemental butyrate might help. You do get some butyrate absorption in the small bowel. Butyrate from the large bowel can actually migrate up to the small bowel and be absorbed in the small bowel as well. So supplemental butyrate might get absorbed in the small bowel, which can help, but it's certainly not going to get to the large bowel. And that's where you really need a lot of the butyrate formulation. So that's why in hospitals, when people have really severe colitis and have really high risk for colon cancer, they do butyrate enemas instead of giving them an oral butyrate, because you want to get the butyrate into the large bowel as much as possible. Now, you also know that propionate and acetate and other derivations of short chain fatty acids are also important. So just getting butyrate by itself will not do the complete picture. When microbes produce butyrate, what they do is they produce acetate and propionate first, which set up a different type of metabolic response in the gut, and then it jacks up the butyrate production by day 2 or 3, which then completes the picture of what short chain fatty acids can do. So it becomes important to get the whole kind of spectrum of short chain fatty acids. So my biggest thing is our body has been designed for bacteria within the large intestines to produce these short chain fatty acids for us. So that's what we should support. Again, trying to outsmart it by taking a synthetic or some other natural form of butyrate orally is just not going to be as effective.
Mm-hmm. That makes sense. Some people came in a little late and they want you to re-clarify how the spores are different, right, from other probiotics, and then how the spores can help with leaky gut. So if you can just...
Sure, yeah. So So just a quick refresh on that. The spores are a unique type of bacteria. They're what we call keystone strains. So as it turns out, there are certain strains within the microbiota that support a lot of the other bacteria within the gut. And it can be as a metabolic support, meaning there's a strain that produces metabolites that are really important to the rest of the microbiota, or it's a strain that regulates the rest of the microbiota. For example, suppressing overgrowth of certain bacteria, increasing the growth of underperforming bacteria, just kind of regulating things. The spores seem to be that type of regulating bacteria. So it seems to change the microbiota. As I mentioned, I got that report just today on our study on 3 separate microbiomes showing that the spores increase the diversity of the microbiome and increase things like Akkermansia, Faecalibacter, and so on, because they're getting in there and they're regulating how the microbiota responds to food and the environment. So that's what's so important about them. Now, the spores also produce high levels of short-chain fatty acids like acetate, propionate, and butyrate, and that high production of short-chain fatty acids increases the mucin layer and also seals up tight junctions. So that's two ways in which it prevents leaky gut. Spores also seem to reduce the inflammatory response of food in the mucus layer of the intestines. That inflammatory response stimulates the production of inflammatory cytokines that open up the tight junctions. So that's another way that spores improve leaky gut and all of the inflammation that comes along with it.
Very good. And then in addition to the spores, what else can people do to help heal leaky gut? We had a specific question about gelatin, but is there anything else you'd recommend doing?
So the biggest thing is that there are 4 essential amino acids, serine, proline, cysteine, and isoleucine, I think, that seem to increase the production of mucus. So the mucus layer that acts as a really important protective barrier are produced by these 4 amino acids. That's the building blocks of the mucus layer. So without adequate amounts of these 4 amino acids, your goblet cells can't produce enough mucus to maintain the barrier function. So taking those amino acids are really important. Those amino acids are in L form. So, we are actually producing a mucosal support product that's coming out that has those 4 critical amino acids in it. But in the meantime, getting an amino acid isolate product like bodybuilders get, or branched chain amino acid products can help with providing the right amino acids so that the mucus layer or the mucin cells, goblet cells, have the right amino acids to produce your mucus. Again, increasing short chain fatty acids by taking resistant starches and prebiotics. That's a big aspect of sealing up leaky gut. And then increasing the diversity of the microbiome. Increased diversity of the microbiome is correlated to an increased protection against leaky gut. What else would there be? Oh, of course, immunological benefits. So colostrum, lactoferrin are compounds that can help with leaky gut by reducing the inflammation in the lining of the intestines, which leads to leaky gut as well. So those are some other things you can do. L-glutamine has been shown to be able to help. Glutamine is a building block of the intestinal lining, but you have to take it in very high doses. It's around 2 to 3 grams with each of your 2 meals, 2 of the biggest meals of the day. So you need to be taking anywhere from 5 to 6 grams of L-glutamine. Aloe could be beneficial. There's no real good studies on it. Theoretically, it could work. And then chlorophyll could work as well, because it reduces the inflammation and increases the repair within the microbiome, within the intestinal lining. So those are some other things: colostrum, lactoferrin, glutamine, aloe, chlorophyll. Those all could be supportive ingredients as well. Now, none of them have been shown in a robust, double-blind, placebo-controlled study to alleviate leaky gut, but just theoretically understanding how they work, they probably provide a good supportive mechanism for leaky gut.
Awesome. All right. Well, you guys have been with us for an hour and a half, so we're probably going to wrap it up. We're super excited that you guys all stuck with us. Pretty much everyone is still here. But any questions that we didn't get to, I will compile. I will get Karan to answer them in a timely fashion, and we will get them out to you guys via email. Thank you guys again for all staying tuned. We had so many good questions. If you guys are practitioners and you are new to us, you can go to our website. It's www.microbiomelabs.com. You can register there to create an account with us. If you're joining us as a patient, a consumer, talk to your doctor about trying Megaspore. If they don't use it and you're trying to find a new provider, you can also go to our website. You can click on the Find a Practitioner tab, type in your zip code, and you'll be able to find any of our practitioners that are near you that do sell Megaspore. And so you can definitely see them. And I think that's everything. We'll get you guys the slides. The replay will be ready in the next hour or so, fingers crossed. And thank you all for joining us.
Yeah, thank you guys. I love seeing all the thank you messages in the chat box. We really appreciate it. You guys spending your evening with us. This kind of education is super important to us, and we're just going to keep increasing what we do when it comes to education. Actually, Keisha and I had a meeting. Was it yesterday? I guess it was yesterday, Sunday. Yeah.
Mm-hmm.
Well, why do we meet on Sundays? Aren't we supposed to be resting?
What
But
day
we
is
were
it?
meeting on, I know, but we were meeting on Sunday, and we were just talking about how we really want to expand the amount of education we're doing, the amount of research material that we're putting together. So more and more stuff is going to be coming up. We're trying to create this kind of microbiome labs EDU, like a little university, to really kind of bring out the specific causes and mechanisms of action that are involved in all of these diseases. You guys being here, joining us, give us the impetus to do that stuff. So a lot more coming up, and thank you again for joining us. And again, I promise I'll get those questions to you soon. I'm
And
not traveling, so there's a good
yeah,
chance I'm not traveling.
just so you guys know, the next two webinars will be on mycotoxins. So we'll have
Yes.
Dr. Andrew Campbell joining us for those. So stay tuned for those, and then we'll have your favorite microbiologist join us back again after those two are done. So
Yeah, and someone mentioned, would I consider being a presenter for something? Yeah, absolutely. If you have a need for someone to present for something, I do 45, 50 presentations in person a year at different conferences. I also speak on a lot of summits. I speak on training modules for RDs, for NDs, for all kinds of people. So, if there's an interest in having a microbiome or any aspect of the microbiome talk, shoot us an email, and we'll be happy to support it.
which email do you want that sent to? Info at?
Info at, or is it info at? Where does that go? They
I'm not
always
really
send it to me though. It's just put it to my attention at info at microbiomelabs.com, and I'll get it for sure.
perfect. We have lots of emails, so I just want to clarify for you guys. All right. Well, thank you all. I hope you have a
Thank
great
you.
evening, and we'll see you again soon.
Thank you. Bye bye.